Okay, welcome everyone, and good morning. It's a bit late to do the last talk of the day, but yeah, this is about my experience in reverse engineering. In the end, rather simple Bluetooth low energy protocol, and I am a total beginner at this. But yeah, I have been doing electronics since I was a kid, taking things apart, sometimes managing to put them back together as well. Sometimes they even worked after that. And yeah, maker, nerd, also motorcyclist, which will become important soon enough. And hackerspaces, Helsinki Hack Lab, Hacklab.fi, you have seen me at the Hacklab.fi stand doing things, playing music, etc. And I work at a consulting company doing machine vision, computer vision stuff. So if anyone has a need for that kind of things at their workplace, remember that and remember me. I also do volunteer work for the Finnish Defense Forces in this project called PV-Arki, Docker, Terraform, and backend web services development stuff. And if you are a full stack developer or Azure specialist, especially CI/CD for GitHub, contact me. We need more good people. And yeah, there's a bunch of links. Maybe the slides will come available somewhere. So the basic idea is that there's a company that makes these very nice electroluminescent decorations for helmets. And then they finally figured out how to make a decent RGB LED decoration as well. So of course I had to get one. Actually, I had to get two of them from their original Kickstarter thingy. And they control them by phone application. The problem is the phone application isn't all that great. And also I have a dream of making a handheld controller for them. So something small that fits in your palm basically. Or you can mount on the handlebar of the bike, though you wouldn't be using these when actually riding in traffic. But I mean, there are hacker camps, for example, where may contain hackers. My bike was there at the actual village, and it has some extra RGB LEDs on the bike as well that are properly interlocked so that they cannot get power if the motorcycle is in actual riding condition. And yeah, I tried to ask for documentation on the protocol, and they denied. No, we are not going to publish the protocol. So challenge accepted. I knew that Mirage existed, and I had dabbled with it once before, a little bit. And then I needed to get some hardware to use Mirage to get actual captures. And then I needed to start analyzing the captures. And once I had the captures analyzed, I could start replaying commands, modifying the commands, doing the usual thing that change something and observe what changes. And as Adam Savage says, the only difference between screwing around and science is writing it down, so make notes. So Mirage. Originally, when I played with it, I was using BBC microbit boards, but I have only one. And the problem is that at that time, only the very first version of the microbit board would work, because it has a radio chip that has a very specific hardware bug. And Mirage abuses that hardware bug to be able to do horrible things to Bluetooth low energy. And the newer version boards do not work for this, which sucked. But I have heard rumors that the newer version boards have since been made to work. And so I did a bunch of research trying to find which actual Bluetooth low energy boards, development boards, etc. have the correct radio chip. And Mirage website also helps with this a lot. So they say that this BLE 400 module or development kit from Waveshare works. And the BLE 400 is used with this. It actually, the development kit comes with this Core 51822 module. And you only need the 51822 module here for this thing. And you need 3 of them for reasons. So I made this fancy contraption, the 3D printed case for three of the waveshare boards with soldered FTDI UARTs. You need RTS and CTS, so you need a good working UART for this. In the end, this revision of the enclosure has a critical bug. It doesn't have any strain relief for the actual USB cables, and I managed to rip out half of the USB connectors, so I can't demo this thing actually working live, the capture stuff. So, yeah. And the basic process with Mirage, you start the Mirage, then you configure it, tell it that you have BBC microbit type devices at these USB ports. And then you start the capture, and then you turn on the application, you turn on the device, and you hope that you catch the initial negotiation so that Mirage can crack the session key. And it works most of the time. And yeah, then what I did is that I captured a video of me working on the phone application and also having the screen, Mirage screen visible so that I can get a time synchronization between the captured packets and what I was actually doing at that time. So, and yeah, there's a link to the video if someone wants to look at it later. I'm not showing it now. And then we have lots of PCAPs. Lots and lots of PCAPs. And this screenshot is after I had spent a lot of time reading GATT documentation and so on. The capture starts in a much worse place, and you just have basically binary garbage and tons of binary garbage. And then you start reading the protocol documentation for BLE GATT, and then you try to get an idea that what are the package that you actually should be looking at, because there's a ton of package or packets that are not actually in any way relevant to what you want to see. And after we have figured that out, then we could find the correct packages that contain the actual payloads that we are interested in. And it turns out it's an actual very simple ASCII serial port protocol. Could be done with just standard Bluetooth serial port profile, but of course low energy is low energy. So that's it. So I made a Python script to talk with the device using Bleak, which is a multi-platform BLE client and also server. Well, BLE doesn't really have clients and servers in that sense. And I was using Bleak to talk to it and making experiments like if I start sending, first of course start just sending values that you have seen before. And then start modifying the values and see what happens. And keep doing that. And that way you get, so in the end we start, okay, these are the pattern commands we have seen, and these are like, now I have enumerated that patterns go from 1 to 999 and so on. And most of the pattern numbers do nothing. But yeah, and also like what are the actual valid values for the HSV colors and so on. And then I made an actual command line tool to do like a proper command line tool that runs both a service that continuously polls BLE for new devices and connects to them and then keeps alive the connection, because the device also has this Maybe good idea, maybe bad idea, but at least it's annoying in my point of view is that once you disconnect from the device, it will completely shut down the BLE. You can't connect to it again without rebooting the device and putting it to the BLE connection mode. So, and also make it Pythonic, make like you have a method that takes actual HSV from like 360 and 100 and 100 instead of the weird values that they actually map to in the protocol. And yeah, and then there's a command line tool that is used to tell the service to send commands to the Bluetooth low energy layer. And yeah, so let's see if we can make a demo. Huh? Can you see anything? So that thing. No. Okay, classic demo effect. Doesn't want to. Okay, now we have blue light and we have a session. And no, that's not it. It's not it either. This looks like the window. Okay. Make it. So basically I can say that, okay, I want pattern 2 and it will change the pattern, and if I get my fine demo camera working, yes, clean up. No. Don't. Open capture device. Okay. Better demo effect. Okay, anyway. I wonder if you can see anything. But basic idea is that let's make it maybe brighter.
I can hold it for you, so you have
Yeah,
that's for keyword.
Yeah. Thank you. So, okay, it should be brighter now. Good. And then we can do different patterns. And yeah. So, yeah, and we could change the colors as well, but then I would have to remember HSV values for some cool colors. But yeah, this rainbow sunset pattern is pretty cool. So yeah, it works. Next, I just need to fix it with ESP32. There is a question there.
How does the product look like? How does it look when it's on the
Well, I mean, you can go to lightmode.com for their fancy demo videos. I haven't yet put this on my helmet because I still have the EL wires. So So this is my helmet with the EL wire. So something a bit similar, but with RGB. And it's documented now. And yeah, there's some links there. The QR code should take to the repo with the actual Python code. The Nightshift BTRE is the working repository for the actual reverse engineering. It has the PCAPs. It has links to the videos, etc. So if anyone wants to try their own hand at this, all the material is over there. And yeah, and then there's the 3D model that I need to make a better one. Any more questions? There. Oh yes, the reason for three Bluetooth low energy modules is that there are three main channels where the initial negotiation can start. And so you need three modules to have the best chance of catching the initial negotiation, because you might miss it. This is all doing horrible things with undocumented hardware features on the radio chips. So if you only have one module, then you have like 30% chance in the first place, and then it might fail because of other reasons. Any other questions? Yeah, just scream your question, because I can't see you. The lights are.
Did they ever respond to the last email?
So the question was, did they respond to the last email? No, they did not respond to the last email. And yeah, that's basically it. It's I am an idiot and you can too, to quote Deviant Olaf. So don't be scared. Just get the and the hardware is cheap. Like I don't remember, it's like $15 for the WaveShare module, and then whatever you use for the UART. Well, that's your budget. The FTDI chips are a bit more expensive than some others, but at least I know that they will work. Yes?
Yeah, I mean, use different hardware, but have you used or do you have tried, Ubertooth 1? How does it compare,
So the question was, have I used Ubertooth 1 or compared to that? No, I haven't used Ubertooth 1. I don't have one, and it's expensive. These are cheap.
Yeah, I get that.
So yeah, that's one of the reasons why it was very easy to get started with it. It's like 50 euros of investment for the hardware and time. And hobbyist time is of course free, as we know. Okay, are we done? Yeah, if someone wants to look at network captures, I can show you some.